Example number 2, determine the deflection 2 meters from the right support and the slopes at both ends. So again, we are going to separate the deflection from the other solution, and also the slope solutions for left should not be in the same solution with the right slope. So we have to solve them and consider them one at a time. So in this in this example, we will be having 3 different solutions, since we have 1 for deflection and 2 for the slopes. So let's start. For the for the deflection, we are going to get the deflection 2 meters from the right support. So somehow this is the point where 2 meters is. So if we are going to do a letter assigned for each point, it's gonna be A. So this is A, this is B, this is C, this is D, and this is E. With that, we are going to also place the P force at point D, since that is the point where deflection is asked, and the direction is the anticipation of the point at which this deflects. So in that anticipation, I would have like this elastic curve. So this is the deflection being asked in the problem. So with that, let us solve for the reaction. We have here RA, and I'll have here RE. Then of course we have the resultant of this distributed load. It's 20 times it's 20 times 4. This is 80. Okay, with that, we can now create the moment equation, or simply getting the equation or the reaction. Summation of moment about point E, so that we can solve for RA times 6, and then plus 60 minus 80 times 2 minus P times 2. Do not forget that P exists. So RA now is equal to 160 minus 60 plus 2P over 6. So we will have RA equal to 100 plus 2P over 6. So what is 100 over 6? It's 50 over 3. So RA is 50 over 3 plus 1/3 of P. That is your RA. And for RE, let's try to have summation of forces vertical. You will have RA plus RE equal to 80 and P. So RA, ato na lang i-transpose to the other side. This is 80 minus P, 80 plus P minus 50 over 3 minus 1/3 of P. So RE is equal to, it's 80 minus 50 over 3. It's 190 over 3. And plus 2/3 of P. So we have now the values of our reaction. Okay, so let us now introduce a segment. We will be cutting this portion. So in that case, let us draw the segment. This is segment AB. So for segment AB, we have here the segment, and then we are gonna place the reaction at RA, since this is point A, and of course we'll have our moment M here and here as X. So summation of moment at the point of cutting equal to 0, we will have M equal to RA times X, where RA is 50 over 3 plus P over 3 times X. So get the partial derivative of M with respect to P. You will have only 1 over 3x. Again, we're gonna set this 0. No? By the way, akong gina shortcut. Ano yung anak ko siya para di mo maglipog. So first, kaya ako sa siyang i-distribute. So it's going to be 50 over 3x plus p over 3x. And you get now the partial derivative of that equation, setting this to 0 since that is now the constant. And with p term will now be considered to be with a variable. Okay, so the partial derivative of x over 3 with the variable p is equal to 1/3 of x, or x over 3. So therefore, the product of the two terms is now equal to 50 over 3x plus p over 3x, multiply it with 1/3 x. So to make it final, the term would be now in, so kani siya permanently set that to 0. And with that, the term would now be 50 over 3x times 1/3 of x. This is for our segment AB. Let us proceed to the next segment. So for the next segment, we will be cutting the BC, and I'll consider the left side. So this is segment BC, and I'll copy this beam. I'll copy this beam. And we'll set the boundary. This is point A, so therefore natay RA there. Then we also have point B, so therefore naa siya'y moment load. And the direction is clockwise, and this is 60. And this point from A to B is no longer x, but rather 1 meter. And from point B to the point of cutting, it's now set to x. Then apply the moment equation, the moment bending. So we are now going to create the equation. So it's M equal to RA times x plus 1, then plus 60. So with that, we will have substitute RA. It's 50 over 3 plus P over 3 times x plus 1 plus 60. Again, this term to be distributed to individual term here. So ato na siyang i-distribute diha. So with that, it's gonna be 50 over 3 x plus 1 plus P over 3 x plus 1 plus 60. And the partial derivative of M with respect to P, so temporarily set the terms nga walay P. So kani sila wala man ay P, set na to 0. And those with p, kay mora atong i-derive, get ang derivative. So it's going to be x plus 1 over 3, or the partial derivative is x over 3 plus 1 over 3. So there. Get now the product of m with respect to the partial derivative. So it's going to be 50 over 3 x plus 1 plus p over 3 x plus 1 plus 60, and you get the x over 3 plus 1 over 3. And this time we are now going to set the term with p to 0 permanently. So therefore, the final equation of the product of m and the partial derivative of m is equal to 50 over 3 x plus 1 plus 60 times x over 3 plus 1 over 3. Okay, next segment. Oh, I forgot. Naaday tay point another here, since this is the beginning of a different section, so I'll just place point F. So C to F. We will be cutting C to F here. And I'll consider the right side. Segment C to F. So with that, let us draw. So let us draw here tanan. Okay. So I'll just draw the beam or the section, and then I'll place the loading. So this is point F. This is point, say next F, D, then E. No, so here. This is D and this is E. And then this is downward here. This is 1 meter. This is 2 meters. And from the point of cutting towards point F, this is X. And place the M, and do not forget to place the P at D. So do not forget to place the P at point D. And also we have a resultant. So the resultant is equal to, how much is the distribution? The distribution is 20. So this is 20 kilonewtons per meter. And also naatay reaction here, RE. So the distribution is 20 times x plus 3, right? So with that, get now the moment equation. So M equal to RE times x plus 3 minus 20 x plus 3 times 1/2 of x plus 3 minus p times x plus 1. So do not forget to simplify. RE is 190 over 3 plus 2/3 of p. Then multiply it with x plus 3 minus 10 x plus 3 square minus p times x plus 1. Okay, so let us distribute this term towards here and here. So the moment equation would be 190 over 3 x plus 3 plus 2/3 of x plus 3p minus 10 x plus 3 square minus p times x plus 1, or balihon na to, x plus 1 times p. Right, so that is our moment equation. So let us now get the partial derivative of the moment equation. So set the value or set the term na walay p equal to 0. So temporarily setting this to 0. Also this one. So mabilin, it's gonna be the partial derivative here is 2/3 of x plus 3. So 2/3 of x plus 3 minus x plus 1. No? Tungod na. So there. Ayun na lang na siya i-distribute since dako og risk kung imo na siyang i-distribute. Okay, so what we're going to do now is get the product of m times that partial derivative. So m, what is the m? So you copy. So bahalag nakaset to 0 na siya ganina, but you have to copy that x plus 3 na. And then plus 2 over 3 times x plus 3p minus 10 times x plus 3 square minus x plus 1p to be multiplied by the term 2/3 of x plus 3 minus x plus 1. And this time we are now going to set the term with p to 0 permanently. So kani nga term na siya p, so 0 na siya, also that 0. So therefore the final equation for this segment is 190 over 3 x plus 3 minus 10 x plus 3 square times 2/3 of x plus 2, x plus 3 rather, minus x plus 1. So that is the segment CF. Let us continue with the segment FD. So for segment FD, we're going to cut this portion and consider the right side. So FD. So here, segment FD. And for segment FD, I'll just need to copy this because I'll be needing that here. So basically, you have to redraw the whole segment. And since we're trying to cut this portion, the FD, so kana siya, ato na siyang i-cut. There, na-cut na siya. So here, This is now the point of cutting, and this is now expressed in terms of x, and of course the moment equation for m. And this time we have to erase this, since that is no longer the location of the resultant, but rather here. And the resultant is no longer, the resultant now is 20 times x plus 2, not x plus 3. Remember, x plus 3 na siya ganina because of that segment CF. Yeah, FD naman ta, so that's now 20 times x plus 2. And same location for our P, since P is applied at point D. And then now we're trying to get the equation. So summation of moment at the point of cutting equal to 0, you will have m equal to RE times x plus 2 minus 20 times x plus 2 times 1/2 of x plus 2 minus p times x. And simplifying, substitute RE. This is 190 over 3 plus 2/3 of p, that's RE, times x plus 2 minus 10. Then this is x plus 2 squared minus px. And finally, it's going to be 190 over 3 x plus 2 plus 2/3 of p x plus 2 minus 10 x plus 2 square minus px. And then get the partial derivative. So we're gonna set this to 0 temporarily, tanang walay p. And with p, it's going to be 2 over 3 x plus 2 minus x. So from here, we can now get the product of m times the partial derivative of m with respect to p. This is now 190 over 3 x plus 2 plus 2/3, ako lang i-rearrange, x plus 2 times p minus 10 x plus 2 square minus px, and you pair it with the partial derivative. It's 2/3 of x plus 2 minus x, and set permanently to 0 the term with p. So kana siya, and that one. So therefore, the term would now be, for this segment, is 190 over 3 x plus 2 minus 10 x plus 2 square to be multiplied by 2/3 of x plus 2 minus x. So let us have the segment, the last segment, D to E here. For the last segment, we are gonna cut here and consider the right side, D to E segment. Then I'll just need to copy this, for I'll be needing the others, and paste it here or redraw that here. Okay, so this time this is D to E. So this is D to E, and then I'll erase this, and this portion here I'll cut here, and I need to erase here everything. And this is no longer 2 meters, and this is now x, for this is the point of cutting, and you have to supply the equation or the rotation m. Of course, we'll have here the resultant. It's now 20 times x. So with that, we can now create the moment equation by having summation of moment at the point of cutting equal to 0. You will have m equal to RE times x minus 20 times 1/2 of x. So I'll just rewrite this. It's 20 times x times 1/2 of x. So substitute RE, it's 190 over 3 plus 2/3 of p times x minus 20 divided by 2, it's now 10 x squared. And then m, distributing that here, it's going to be 190 over 3x plus 2/3 of px, or 2/3 xp, which however you wanted to write it down, as long as naa si x, naa si p, and everything else. Okay, so 10x squared minus, then temporarily set this to 0, for we are going to get now the partial derivative of m with respect to p, and that is equal to 2/3 x. And this time we are now going to get the product of m and the partial derivative of the function, and that's equal to, you rewrite 190 over 3x plus 2/3 xp minus 10x squared, multiply it with the 2/3 x, and permanently set this term with p equal to 0. So the final equation of this term, or of this segment, is 190 over 3x minus 10x squared times 2/3 x. So I need to transfer it here so I can save spaces. Also this one. Here. Okay, so this time let us now create the deflection downward, and that's equal to 1 over EI for segment AB, m times this one dx from A to B. So the limit is from 0 to 1, since the length of AB is 1 meter. Then plus 1 over EI. So by the way, I'm rewriting 1 over EI because our section is irregular. We have 1 I here and you have 2 I's here. So mag-start ang 2 I's when we reach FD section. So FD to DE. Kaya mag-start atong 2 I's. Alright. So from AB to BC, 1 I lang siya. So it's m times the product of the partial derivative of dx from B to C. So this is 0 to 1. And then plus 1 over EI. This is for the integral of m times the partial derivative of this function from from C to F. This is 1 meter. No, so you have 3 meters already, and plus 1 over 2 EI na ta, because this is for F to D, and this is 0 to 1. Then plus 1 over 2 EI gihapon for segment D to E. So m times the partial derivative dx. So this is for DE. So this is 0 to 2 nga limit. Okay. So what we're going to do now is copy the integral. So downward deflection equal to 1 over EI integral from 0 to 1. So copy segment AB. So where is segment AB? Here. So copy that. Paste it here. Dx. Then plus 1 over EI gihapon for BC. So this is 0 to 1 gihapon. So copy BC. Where is BC? Here. This is for BC. You are going to copy that. Paste it here. BC. So this is dx. Then plus the integral, the 1 over EI. Still 1 over EI because we are still in CF. Limit is from 0 to 1. CF. Where is CF? Here. So we need to copy this and paste it here. Dx. Don't forget that. Then plus here 1 over 2 EI. The integral from 0 to 1 nga limit. So this is for segment CF. CF. Where is CF? Oh, may shortcut ko. AB, BC, CF, FD nta, FD di ay. So FD here. Copy FD. Ato sana siyang i-move here. And then paste this one. Dx. And then lastly, plus the integral. So this is from 0 to 2. So where is the segment? Here. This is the segment. And paste it here. Dx. Okay. So let us continue. So for the integral, downward, it's 1 over EI for this one. Let's start. For segment here, kana siya. It's 50 over 3 x times x over 3 or 1/3 times x, and the limit is from 0 to 1. It's 50 over 27 plus I'm just going to get all the 1 over EI terms. So kani sila mga 1 over EI ni sila, and get the integral of 50 over 30 times x plus 1, and then plus 60, and you multiply it with x over 3 plus 1 over 30, and the limit is from 0 to 1. So this is 1160 over 27 plus The last 1 over EI is here. This one. So you get the integral. It's 190 over 3 times x plus 3 minus 10 times x plus 3 square and times 2/3 of x plus 3 minus x plus 1, and the limit is from 0 to 1. So this is 4435 over 54. And I will close this now, for I will now have the 1 over 2 EI. So 1 over 2 EI, this one, this is for the 1 over 2 EI. So it's the integral of 190 over excuse me, over 3 times x plus 2 minus 10 times x plus 2 square times 2/3 of x plus 2 minus x, and the limit is from 0 to 1. So this is 5965 over 54 plus so we are now in asa na siya? Nawa naman siya. We are now in hala na tsaka na siya darada. So the integral for this one, this is 190 over 3 x minus 10 x squared times 2/3 x. So the limit is from 0 to 2. So it's 190 over 3. Okay, so that would be 85.926. Oops. Alright. So the integral is, so all we have to do now is get the sum of 50 over 27 plus 1160 over 27 plus 4435 over 54 plus, so this is 1 over 2 for this one, 5565 over 54 and 85.926. So the answer is 1 over EI for 221.435. kilonewtons cubic meter. This is now the deflection 2 meters from the right support. So this is the first part. So let's have the solving for the slope at the right support. So as you observe, we have here a different illustration of the beam. So I opted to have this beam as clean para denoting that it's not the same sa previous na solution. And then I won't be placing any point here since we will not be solving for the deflection. So instead, I will now be placing the load to which slope is being asked. Here, we are asked to solve for the slope at the right support. So this is the point of the right support, and I will be placing here the rotational moment m prime in the direction of my assumption. That's my assumption. So whenever slope ang gipangita, do not apply P force. Instead, it's going to be a rotational moment m prime. With this, we can now write letter from left to right. So let's call this A, this one is B, this is C, and so here wala na siya letter diha because it's no longer deflection. And but here we are gonna place here a point D since this is the portion of the transition of the cross section. From the left side it's I, then on the right side it's 2I. So there is a change of cross-sectional area. And then at the point here, we have point E. So this time, let us solve for the resultant here in the 4-meter distribution. So this is 80 kilonewtons. And we have this reaction at A and reaction at E. So let's solve for the reaction, summation of moment about point E so that we can solve for RA. So it's RA times 6 and then plus 60 minus 80 times 2 and then minus m prime equal to 0. So in this case, we are gonna have RA equal to, to transpose on all the terms. So this is going to be negative 60 plus 160 and then plus m prime over 6. So RA is equal to 60 negative and 160, it's 100. So it's 100 over 6, then plus m prime over 6. So with that, or we can simplify it to be having 50 over 3, then plus m prime over 6. So that is our RA. Then let's solve for RE by having the summation of forces vertical equal to 0. You will have RA plus RE equal to 80. And since RA is already known, then must be having 80 minus 50 over 3 and m prime over 6. So RE now is equal to 190 over 3, then minus m prime over 6. That is our RA and RE. So let me just highlight this, that this is for RA and this is for RE. So later on we will be needing those terms. So for the meantime, let us now cut a section. For segment AB, we will be cutting here and considering the left section or side. So this is segment AB. And what we're going to do here is we're going to illustrate the section. So this is the section, and I will be placing point A, and this is its reaction RA, together with the moment m and also the boundary limit x. So in this case, we can now have the summation of moment at about point of cutting equal to 0. You have m equal to RA times x. And remember, RA is equal to 50 over 3, then multiply x, then plus m prime over 6 multiply x. Okay, so since we are going to get the partial derivative of the function m prime, then it's going to be, we will be setting the term nga walay m prime to 0 for the meantime, and we will only be considering that as our derivative. So it's going to be x over 6, since the m prime now is the variable and the x over 6 is the coefficient. Okay, so with this, we can now rewrite that the product of the two terms here is equal to 50 over 3x, then plus m prime over 6x times x over 6. And this time, we will now be setting permanently the m prime to 0. And therefore, the final product of the term would now be 50 over 3x times x over 6. So that is for the segment AB. Let's proceed to our next segment. So can I just arrange this? So let us proceed to the next segment. Our next segment is for segment BC. And by that, we will be cutting through BC and consider the left section, since it's quite convenient to consider that. So let us draw the beam or the section for that segment, and let's label it. From A, there is RA, and then from B, there is a 60 rotational load, and the distance from A to B is 1 meter, and the distance from B to the point of cutting, it's no longer 1 but rather x function. And do not forget, at the point of cutting, we're gonna place m. In this case, we are now ready to formulate the equation. Summation of moment at the point of cutting equal to 0. You will have m equal to RA times x plus 1 minus or plus, so plus 60. And then we're gonna have RA to be 50 over 3 plus m prime over 6, then x plus 1 plus 60. And simplifying further, it's going to be 50 over 3 times x plus 1 plus m prime over 6 times x plus 1 plus 60. And this time, since we will be getting the partial derivative of m with respect to m prime, we will be setting the value of the terms with no m prime to 0 for the meantime. And we will be considering the m prime to be the variable, and the coefficient, you have to copy the coefficient. It's now x plus 1 over 6 there. So with this case, the product would be now equal to 50 over 3, just copy the m, the final m, then plus m prime over 6 x plus 1 plus 60, and do not forget the partial derivative function x plus 1 over 6. And this time, the final product of the two terms is equal to, since we will now be setting m prime to permanent 0. So here, it's going to be now 50 over 3 x plus 1, then plus 60 to be multiplied by x plus 1 over 6. That is for the segment BC. Let us continue to segment CD. So for segment CD, all we have to do is cut the CD and consider the right side, since it's simpler to consider the right side compared to the left side. Remember that in the left side, you will be considering the distribution, the rotational 60 kilonewtons, and the RA. Whereas kung sa right side ang atong i-consider, we're gonna only mind about the distribution and then the reaction and the M prime. So, and then no other things. Let us continue in drawing the CD segment. So for CD, we have here CD segment CD. It's going to be, let's copy the beam and also the loading. So this is the loading, and this is 20 kilonewtons per meter, and this is point E, where you have RE, and at that portion you also have this M prime. Then this is point D, where the distance from D to E is 3 meters, and the distance from D to the point of cutting is equal to x. At the point where the point of cutting is, you have the moment M. And in this case, we can now get the resultant. It's going to be the product of 20 times the distribution length, which is x plus 30. So let us continue. Summation of moment at the point of cutting equal to 0. You will have M equal to RE times x plus 3 plus M prime minus 20 times x plus 3 times 1/2 of x plus 3. So simplifying, you will have 190 over 3, then plus, or minus rather, is this minus? Yes, minus M prime over 6. So it's M prime over 6 times x plus 3, then plus M prime, and then minus 10 x plus 3 squared. So this time, let us distribute the x plus 3 to each term. So 180 over 3, then x plus 3 minus M prime over 6, then x plus 3, then plus M prime minus 10 times x plus 3 squared. So here we will be setting the values of M prime, all those without M prime, to 0 for the meantime, and get now the partial derivative of M with respect to M prime. So it's going to be negative x plus 3 over 6 and plus 1. So the final product of M times the partial derivative of M prime, it's gonna be 190 over 3 x plus 3 minus M prime over 6 x plus 3, then plus M prime minus 10 times x plus 3 square. And do not forget to multiply them. So can I just transfer them a little bit closer here, since we will be having the next one, which is 1 times, I'm rearranging by the way, it's x plus 3 over 6. And then this time, those terms with m prime will now be permanently be set to 0. So now the final product of m times the partial derivative of m with respect to m prime, it's now equal to 190 over 3 times x plus 3, then minus 10 times x plus 3 square, and multiply this all to 1 minus x plus 3 over 6. This is for segment CD. Let us continue to our last segment DE. For segment DE, all we have to do is cut this portion and consider the right side. And let's draw now the cutting. So this is, so I'll just cut now the portion. So that is the portion of cutting, and apply the load. And of course, do not forget, this is a 20 kilonewtons per meter, where this is RE, since you have point E here. And of course, you have this rotational M prime, and this is the point of cutting, M, and at this portion, this is X. Then the product or the resultant is now 20 times X. So in this case, we are now going to get the moment equation. So the moment equation at the point of cutting is equal to M equal to RE times X, and then plus M prime minus 20X times 1/2 of X, wherein RE is 190 over 3 minus M prime over 6 times X plus M prime minus 10X squared. And simplifying further, the moment equation is equal to 190 over 3x minus m prime over 6x plus m prime minus 10x squared. And those without or with no m prime, set them to 0 first for the meantime. So now the partial derivative of the function is now negative x over 6 plus 1, or that's 1 minus x over 6. So therefore, the product of the two terms, which is essential, we now have to write 190 over 3x minus m prime over 6x plus m prime minus 10x square, and you multiply it with 1 minus x over 6. And this time we are going to set the m prime, all the m prime, to 0 permanently. So therefore, the final term would be 190 over 3x, then minus 10x squared, to be multiplied by 1 minus x over 6. So this is. So let us now continue with the slope. The slope is equal to the 1 over EI of the integral of m times partial derivative of m with respect to m prime dx, and this is from a to b. So the limit is from 0 to 1. So basically, let's just copy this for the other segments. And then let's proceed to the next one. This is for B to C. and the same limit 0 to 1 since B to C is 1 meter in length. Then plus the next segment, it's gonna be for C to D, and the limit is still 0 to 1. And for the last one, it's going to be plus, and this is for D to E. This time the limit is 0 to 3, and of course this is 2EI there. And our assumptions or the direction is counterclockwise. So whenever we arrive the value of slope negative, then this counterclockwise is in the wrong direction. So let's start. So we have 1 over EI for the first integral, 0 to 1 limit for AB segment. Let's copy the segment AB. Where is the segment AB? Here. Let's copy that and paste it here. Dx, then plus 1 over EI, the integral from 0 to 1 in a limit of BC. Where is BC? Here. Here it is, BC. Let's copy this, BC, and then we're gonna paste it here. So the same limit 0 to 1 dx, then plus the 1 over EI of the next integral, the same limit 0 to 1 for CD. So where is CD? Here is CD. Let's rewrite it here. And the limit is still from 0 to 1. And the last one, it's going to be 1 over 2 EI, the integral from 0 to 3 limit. So it's gonna be this one. Let's copy this, paste it here, and then there. Let us now continue. Since our assumption is clockwise, counter, let us have the 1 over EI for all the terms. So kani siya 1 over EI ni sila tanan except sa kani. This is 1 over 2 EI. So let's start. So the integral would be 50 over 30 x. Oops, what happened? X, and then times x over 6, and the limit is from 0 to 1. So the answer is 0.9259 plus. We have the next integral. It's gonna be 50 over 3 times x plus 1, then plus 60, and you multiply it with x plus 1 over 6. Close it, and the limit is from 0 to 1. So that's gonna be 21.481 plus the next integral. So let's transfer it here. It's going to be the integral the integral of 190 over 3 times x plus 3 minus 10 times x plus 3 square, and you multiply it with 1 minus x plus 3 over 6, and you close it. The limit is from 0 to 1. So this is 41.065. So these are the three terms that we will be using in 1 over EI. And for the 1 over 2 EI, we only have one. It's going to be the integral of 190 over 3 x minus 10x squared times 1 minus x over 6, and you close it, and it's from 0 to 3 nga limit. It's 133.75. So the slope in the direction nga counter clockwise is equal to 1 over EI. So let's get all the terms. 0.9259 plus 21.481 plus 41.065 plus 1/2 of 133.75. So the answer is 130.347. The unit is kilonewtons square meter. And we obtained a positive value for our slopes assumption is correct. So let me just have the label here. Slope at the right support. Okay, next. So continue to our still the same problem, but this time we're gonna solve for, oh no, same item but different problem. We're gonna be solving for the slope at the left support. So basically we're gonna be having the same letters from the previous: A, B, C, and then D here with E here. And we will be placing, since we are asked to solve for the support's slope at the left side, then let's have this assumption of our M prime. And in this case, we will be solving for the reaction of our RA and reaction for our RE together with this 80 kilonewton resultant. So by that, we will be getting the summation of moment about point E equal to 0. You'll have RA times 6 plus M prime, and then plus 60, and then minus 80 times 2 equal to 0. So RA is now equal to negative 60 plus 160 minus M prime over 6. And RA now is equal to 100 over 6 minus M prime over 6, or this is 50 over 3 minus M prime over 6. So this is our reaction, and we will be solving for RE, which is 80 minus RA. So that would be 80 minus 50 over 3 plus M prime over 6. So RE now is 190 over 3 plus m prime over 6. And let's move it to the right side. So this is our reaction. Let us proceed to the segment. For the segment AB, we will be cutting this here and considering the left section. So let's draw the segment or section. So let's just borrow the section from the previous here. Let's borrow that and paste it here. Basically, ang ibutang ra nato diha is the m prime. So that is our m prime, and we have the same output for m. So summation of moment m equal to 0 at the point of cutting. You will have m equal to RA times x plus m prime. And then RA is 50 over 3 minus m prime over 6 times x plus m prime. So m now is 50 over 3x minus m prime over 6x plus m prime. And let us now set this term to 0 for the meantime, since we will be getting the partial derivative of m with respect to m prime, and that is equal to negative 1 over 6x plus 1, or that is 1 minus x over 6. Now they're just the same. Okay, so let's get its moment product. So it's going to be 50 over 3x minus m prime over over 6x plus m prime to be multiplied by 1 minus x over 6. So the product would now be, set this to 0 for those na ay m prime. And this is now going to be 50 over 3x times 1 minus x over 6. That is our segment AB. Let us proceed to our segment BC. So the same, we will be cutting the segment BC here and considering the left section or segment. And for that, let us just borrow the segment BC from the previous BC here. This is the segment BC. And let's paste it here. So this is for BC. And of course, do not forget that at point A there is m prime. So let's now get the moment equation. At the point of cutting equal to 0, you will have m equal to, it's going to be RA times x plus 1, and then m prime, and then 60. So you will have here RA to be 50 over 3 x plus 1 plus, or minus rather, minus m prime over 6 times x plus 1 plus m prime plus 60. And we're gonna get the partial derivative. So partial derivative of m with respect to m prime, and we will be setting this to 0, the terms nga walay m prime, and that would be negative 1 over 6 x plus 1 plus 1, or that is 1 minus 1 over 6 x plus 1. So if we try to get the product of the two, m times the partial derivative of m prime, it's going to be 50 over 3 x plus 1 minus m prime over 6 x plus 1 plus m prime plus 60. And then you multiply it with 1 minus 1 over x plus 1. And then we will be setting the value m prime to 0 to get now the final equation for this segment. So partial derivative of m with respect to m prime, it's going to be 50 over 3 x plus 1 then plus 60 times 1 minus 1 over 6 x plus 1. So that is for the segment BC. Let us continue with the next segment. So for the next segment, we will be cutting CD here and segment CD. So for segment CD, let's just borrow the previous segment CD here. Let's borrow this one. And then paste it here. So gonna want na siya. Right, and of course this portion here, no? So this portion here wala na nailabot diha. So ato na siyang i-reson because wa naman na siya diha dapita. Okay, so the same gihapon ang boundary limit. Right now wala na tayo makitaan. No, mo naman lang na siya atong makitaan. Diba? So wala po nailabot. Okay, dili naman na siya 80. No, so only that section or only that loading ang atong makita. So here is the illustration. And let us now get the moment equation. So summation of moment at the point of cutting equal to 0. You have m equal to RE times x plus 3. So minus, I'll just do the shortcut, 10 x plus 3 square, no? And then m equal to, or ay na lang, pakita na lang nato. It's going to be 20 times x plus 3 times 1/2 of x plus 3. And then RE is 190 over 3 plus m prime over 6 times x plus 3 minus 10 times x plus 3 square. And then you distribute the x plus 3, so it's now 190 over 3 times x plus 3, then plus m prime over 6 times x plus 3 minus 10 times x plus 3 squared. And we will be setting the value, those walay m prime, to 0 so that we can now get the partial derivative of m with respect to m prime. It's now 1 over 6 x plus 3. And with that, we can now get the final output of the two products, of the product of the two equation. It's now 190 over 3 times x plus 3 plus m prime over 6 x plus 3 minus 10 times x plus 3 square times 1 over 6 x plus 3. And this time we will now be setting the value of m prime to 0 permanently. So the final product would be 190 over 3 times x plus 3 minus 10 times x plus 3 square times 1 over 6 x plus 3. There. That is for the segment CD. Let us continue for the segment DE. For the segment DE, we will be cutting this through here and consider the right side. So let's borrow the segment DE from the previous here. This is the segment DE. And let's paste it here for segment DE. And then, of course, this is no longer part, it's a solution. And let's get the moment equation. So summation of moment at the point of cutting equal to 0. You will have M equal to RE times X minus 20X times 1/2 of X. And RE is 190 over 3 plus M prime over 6 and then minus 10x squared. Oh, I forgot that there is x, then minus 10x squared. So distribute the x. It's now 190 over 3x plus m prime over 6x minus 10x squared. And we are going to get the partial derivative of m with respect to m prime. So I'm gonna set this to 0. And the partial derivative of m with respect to m prime is 1 over 6x. And with this, we can now get the product of the two. And that's going to be 190 over 3x plus m prime over 6x minus 10x squared times 1 over 6x. And we are going to set now all the m prime term to 0. And this is now the final product. That's going to be 190 over 3x minus 10x squared times 1 over 6x. So these are... So this time we will be getting now the slope, and we assume that the rotation would be like that, and it's going to be the integral of all the segments. So let's just copy this portion here since they are just the same. There. So what we're going to do now is get the 1 over EI for every term, integral for AB from 0 to 1. So where is the segment AB? Here. Let's copy this. This is for AB times dx plus 1 over EI for the integral from 0 to 1 limits sa B to C. So let's get the B to C equation. So this is B to C. Let's copy this one. There. This would now be dx. And for the third one, the limit is still from 0 to 1. So this is CD. So let's copy this and paste it here. dx plus, oh, I forgot. There should be 1 over EI here. And here is 1 over 2 EI. Integral from 0 to 3 ng limit. And we will be copying this. x. Okay, so let's get now the slope with the rotation to be clockwise, starting with 1 over EI. So it's going to be the integral of 50 over 3 x times 1 minus x over 6. The limit is from 0 to 1. So it's going to be 7.407 plus the next term. It is the integral of 50 over 3 times, limit, times x plus 1 plus 60 times 1 minus x plus 1 over 6 times, or close it from 0 to 1, limit. That's 63.519 plus integral of, so I'll transfer it here, integral of, integral of 190 over 3 x plus 3 minus 10 times x plus 3 square, close it, times x plus 3 over 6, and the limit is from 0 to 1. So that's 57.268. Then plus, no, not anymore, but rather we're gonna close that since that's only for 1 over EI. Let's proceed to 1 over 2 EI, which is only one term. So it's going to be integral of 190 over 3 x minus 10 x squared times x over 6 from limit 0 to 3. That's 61.25. So with the slope and the direction clockwise, it's going to be 7.407 plus 519 plus 57.268 plus 1/2 of 61.25. So the answer is we have 1 over EI from 158.819 kilonewtons square meter. So let's check if we got it correctly. 158.819. So it seems that we have the same answer from the previous method. So this is now our slope at the left support.